What if I told you that in a powerful explosion, even if you don't see it, even if you don't hear it immediately, the air is already moving toward you. Fast. Extremely fast. Faster than your brain can react. Part 8. Speed of shockwaves. In normal life, sound travels through air at a certain speed. But a shockwave, it breaks that limit. It moves faster than sound. This is what scientists call a supersonic wave. A wave so fast that the air in front of it doesn't have time to move away. Instead, it gets compressed instantly. Imagine air molecules being pushed together violently, like a crowd suddenly squeezed in one place. That sudden compression is what creates extreme pressure. And pressure is what causes damage. Part 9. Pressure versus time. Here's something very important. Damage from explosions is not just about force. It's about how fast the pressure changes. In everyday life, pressure changes slowly. Your body adapts. Buildings remain stable. But in an explosion, pressure rises in milliseconds, then drops just as fast. This sudden change is what makes shockwaves so dangerous. It's not just being hit. It's being hit instantly. Part 10. Why structures fail. Buildings are strong, but they are designed for weight, wind, slow forces. They are not designed for sudden pressure spikes. When a shockwave hits a wall, the force arrives instantly. Before the structure can react, it's already too late. Windows shatter first, because glass cannot flex. Then walls begin to crack. Then entire structures can collapse. All in less than a second. Part 11. The deadly second wave. Most people think the explosion is just one blast. But that's not true. There are actually multiple phases. First, the air is pushed outward violently. Then, it rushes back. This creates a second wave, a reverse force. So objects are pushed away, then pulled back. This back and forth motion creates even more damage, even more stress. Part 12. How your body feels it. Your body doesn't just experience impact. It experiences pressure. When a shockwave passes through you, it moves through your body. Air-filled organs are the most sensitive. Your ears can lose balance instantly. Your lungs can struggle to handle rapid pressure change. And your brain may not even understand what happened in time. Because everything occurs so fast. Part 13. Long distance effects. Here's something surprising. You don't have to be close to feel an explosion. Shockwaves can travel long distances. As they move, they lose energy. But they don't disappear immediately. That's why, even far away, windows can still shake, doors can still move, and people can still hear the impact. The air carries the energy across space. Part 14. Air is a medium of power. Air is not empty. It is a medium. A medium that carries sound, heat, pressure, energy. During an explosion, all of these combine. The air becomes a pathway for destruction, but also a pathway for understanding physics. Part 15. What science teaches us? When we study explosions, we are not just studying destruction. We are studying energy transfer, motion, pressure. We are learning how forces behave under extreme conditions. And this knowledge is used in many areas: engineering, aviation, safety design. Final outro. So next time you think about air, don't think of it as nothing. Think of it as something powerful, something invisible, but capable of carrying enormous energy. Because under the right conditions, air can become a force that moves faster than sound, stronger than structures, and impossible to ignore. And the question is, if we can understand this power, can we learn to control it? Subscribe for more deep science content. Because science doesn't just explain the world,